Today we are on a new topic that is functional programming. Basically, this session is set up for question and answer, but so far I do not see any student coming in yet. So I'll get started to discuss the topic shortly because this one only to give you the guideline of what you need to study this week for the class. And we expect more students to come in for question and answer, but so far we still don't have any person coming in yet. Anyway, sorry. We'll get started. So this week we are on functional programming, and functional programming we have two lectures, so it'll be lecture 7 and lecture 8. And then I call it this is chapter 6A and 6B. Okay. So first let's go over the functional programming. So basically, you need to know about the concept of the functional programming. What is a pure function? What is recursion? What is referential transparency? What is a first class membership? And or can be higher order functions. So these need to be discussed. And why the variables are immutable. Okay, so these are different features of functional programming, and they are very important when you talk about functional programming. And functional programming with these different features make it very unique. Okay, so first one is that, okay, we go back to review the programming paradigms. They are imperative programming and also declarative programming. And functional programming is considered to be declarative. And so far we have touched in the imperative programming and object-oriented programming so far. This one, functional programming, actually is more declarative. So it actually usually is rule-based. And it actually is inferential-based. So basically, it's rule-based. It's different from imperative programming that you actually are going from step 1, step 2, step 3, and going to like a structural programming or procedural programming. You write a function in the conventional structural programming. Functional programming instead is actually using the function calling function, and then there's an inference engine, reasoning engine that want to find out which function match better, that give you the rule-based programming. So basically, the overall programming paradigm is different. You need to understand the rule and then try to come up with different way of programming. So here list down the languages for different programming scheme. So here, Python is what we are going to use, and we also use scheme language as an example. So functional programming, actually, this is human, this is cheap. Okay, so if you add abstraction, a little bit of abstraction, from your machine code, you go to high level languages. And then human actually is more abstract. So you subtract some abstract, you put them into rules, then you come up with the Lisp, OGO language, ML language, Haskell language. So you put your knowledge or your concept into rules, this becomes that. And then there is a certain hybrid language meeting between machine and the human, okay? So functional programming is closer to math, closer to human abstraction, less machinery. Functional programming is a programming paradigm in which we try to find everything pure mathematical. It's more human, okay, more human abstract concept. It is a declarative type of programming style focused on what to solve instead of what the machine can offer. Okay, this is actually primary difference between functional programming and imperative programming. An expression is evaluated to produce value. So each expression is a evaluation, and they may call some functions. Okay. So why should I use functional programming? It will produce fewer bugs because you calling function based on rule base. There's not very few chance that you write some wrong code. Coding is simpler because it's more conceptual, less detailed programming. No side effect function is pure, so there's no side effect built into the function. Easy to parallelize or scale, so good for parallel programming. Mathematically provable because it's closer to math. And it has been around for a while since math is invented. Using the lambda calculus, you already have the function. So functional programming core concept is functional-oriented expression rather than statement. You have expression, calling expression, algebraic type, pattern matching. Pattern matching is very important. Your control flow is managed by pattern matching, not by the flow. So you need to know about what is immutable data, what is first-class function, what is recursion, what is tail recursive call optimization, what is mapping, reducing, pipelining, querying, higher order function, and lazy evaluation. These are different concepts, but these are terms that you need to know. So functional programming's main idea right here, okay? We don't repeat one more time. And then these are different the features that for functional programming. These are features. These are the advantages. So no side effects. Here on the left-hand side, you have the so-called traditional Python programming. So this one, you have the global variable, and you change the value for a global variable. Okay, and then you do have side effect because you modify the value right here. This, you don't have side effect. You just return the plus sign on the two data. Right here, these two data maybe is string. So in that case, you become concatenation. If it's numbers, then you produce the value. So basically right here, you just apply the plus sign onto the onto the data, and you return it, and you would no change your original data. Here, the data outside global variable may be changed. So here you know side effect. Left-hand side has a side effect. Both are written down in Python language. So language, there's no difference. Here, let's look at the higher order function using map. So map is a higher order function. Basically, higher order function means that you can put a function as input into the function. So lambda is a lambda function, is an anonymous function being put over here, and here you have a variable. So this map take one function and one value. So apply this value to the function, okay, or apply this function to the value. So this one is called higher order function. Left-hand side is imperative programming using Python as well. You have a list. You actually use a for loop to create a new list. Okay. This is another higher order function called filter. You have a function, and that function will create Boolean value. And you use this one to evaluate the function. So basically, the x is a is a list, is an array, and you apply the lambda function to filter the list, and then that remaining list will be applied with a function. So that remaining is every element will be increased by 5 times. Okay, so basically this is the same as this one. So it's using two functions, two higher order functions. Okay, this one actually just a follow. And you can also use reduce. So the major function that people always use for the functional programming is map, filter, and the reduce. So map, you apply some function to it. Filter, you kind of apply the function to select some elements. Reduce right here, let's look at reduce. Reduce to create an aggregator function. This reduce is putting things together. We call it reduce. Okay, reduce the complexity or reduce the grouping. So left-hand side is you use a sum to apply on that. This is a function you call it. This one you use a plus sign between two values. So every time you have sum of these two, and the result sum up with it, and the result sum up with it, and the result sum up with it. This is called reduce. Okay, 1 by I reduce. So you can write it in Python 3.5 version or 2.5 version, version 2 or version 3. Version 2 provides a reduce function in functional programming. And version 3, you need to use a function tools reduce. So this one no longer a built-in function. It is a function in the module of the function tools. But this one is the third function used in higher order function for functional programming. Hi, how are you? Good morning. Okay, let's continue. So next one is tail recursion call. Tail recursion call actually, you have the left-hand side that's actually tail recursive. Right-hand side is not tail recursive. The main difference is that non-tail recursive, after you finish some calculation, you still need to work on some operators. Then that's not tail recursive. This one is tail recursive because after you finish subclasses, you do not need to actually do any more operations. So this is tail recursive. Tail recursive recursive call will have the advantage of being optimized by the compiler. Okay, partial function. Partial function is that you have a function, originally you have 3 parameters. Now you actually create a new function that you fix 1 parameter, 2 more variable. So right here you have degree of freedom of 3. Now your degree of freedom drop to 2. So only 2 variable. So in this kind of the reduction, we call it partial function. Okay, partial function. Because only 2 parameters are now moving, 1 is already fixed. Okay, it's called partial functions. So here we have a log function, and then we have a print for this. So partial function that we can fix a parameter with a server, and then this create a partial function called server log. So server log is a partial function of the log function. It takes only 1 parameter. Now it's only the message part is a parameter. The subsystem already been fixed. So server log is considered to be a partial function of the log function. And then next one is called pipeline. Pipeline is not in Python. Okay, so pipeline is almost like a composition of the functions. So left-hand side is imperative programming. You do have a for loop, and then the for loop is inside the format band. So you have a band, and then band in band. Each band in band, you have assigned a function value to it. Okay. So this one is a format band. You apply a format band to the bands and you print it. Okay, this one is called regular Python programming. Right hand side is called pipelining. So you do uh, pipeline each data and function. You apply the data with the function. So this is a function being put over there, and you do reduce map x. So you map lambda a and x. I think is a function. So function with a, okay. A is value. A probably is array. X is a function. You map the function to the array. This is a map function. Okay, this one is a mapping function to array. And then we do reduce. Reduce is there's a function, and then here you have data. You have a function, and you reduce. Reduce with actually provide an aggregate feature of the map function to the functions. Okay. So this one is, I think this is 3.5. Okay, 3.5. And then this one, you can also use pipeline each. Okay, pipeline each pen and call this Canada country lambda replace that with name and title name. So these two actually equivalent to this one, and pipelining is you put function call after function call after function call. Okay. Okay, anyway. Pipelines is one feature in functional programming, but Python basically does not support it. You have to write a different way to pipeline the function code, but not really pure pipeline in functional code. Okay, so here you have quite a lot of topic related to functional programming. So in a way, what is the major difference between functional programming and regular programming? This one tell you the idea. So traditional programming, you have a function. So that you do have a function, let's call it f. And you will put some input for it. So you have some variable that's as soon as x, and you will produce y equals f of x. So this type of function is what we say vector input and vector output. That's the regular function. Okay, that's a regular function. So right here, you also have input as vector, output as a function. That's called function vectoring. You have input as function, output as a vector, that we call it functionals. Okay, let's look at these two. So right here, you may have a function, So this function, you take a function as input. Sometimes also may have data. And you provide a new function. So this function equal to the function that actually get function input and data. So if you don't have a function input, you only get the data. You create a new function. That's also function factory. And you may also have a function as input. Okay. So this one is the called function factory. So if you have a function and then you have a function as input, then you provide result. And this one, we call it functional. Okay, so this one is more like you actually have a map function and then you map in certain function that's assumed that actually is x squared function to x. Okay, this is called functional. For functional programming, usually talking about map, filter, reduce, and sometimes the pipeline. Okay, sometimes the pipeline. But pipeline is not supported in Python. Okay, but this is called functional. Functional programming is using function as input, provide value. That's called functional programming. Functional. Okay, so last one is you have function input, function output. So use a function to multiply function. That's called function operators. Okay. So these are different way of doing functional programming. Okay. So traditionally, you have object-oriented programming. Here we have comparison between functional programming and object-oriented programming. So here the key three important functional programming functions. Okay, so that's next one. We talk about functional programming. Now next one is talking about functional programming in Python. So here you need to know what is a pure function. Pure function is a function whose output value follows solely from its input values. So pure function means that you get input, you produce output, and you have a function. The function is purely, output is purely depending on the input. That's called pure function. So there's no side effect. You don't put more parameter or something in the middle to create a change. Okay, that's pure function. No side effect, no side effect. Okay, purely argument and return value. That's called pure function. Functional paradigm, you actually here make it high level, more abstract, transparent, parallel, run purely in parallel. Okay, so here is the feature of functional programming. Again, that's so first one is first citizen. Okay, first class citizen for functional programming. This is very important. Python has it, but Java does not have it. So what is a first class citizen? A first class citizen means that you can be put anywhere as it should be. So a function is a first class citizen if the function can be put as a parameter and also the return value. Okay. And anywhere it should be. Okay. So some language you cannot put a function as a parameter like Java. Then it's not first class citizen. A first class citizen is that you can fit anywhere it should be and perform as that. That's called first class citizenship. Okay. So in Python, functions are first-class citizen. It can be put anywhere it should be, as a parameter, as a return value, as a function call. Okay. So in Python, function are actually objects, so it can be assigned to variables. It can be assigned as a property of an object, and it can also be a functional literal. So that's called first-class citizenship, and also can be passed as a function argument, and can be passed, can be returned as function result. So function can be everywhere. It's a first-class citizen. Okay, so here are example. You can do it as a function call, and the function can be assigned as a variable. It is an object by itself. Is an object. So here we have a function, and function can be a parameter, and function can be put as a element in the array. So you call the object 1, then you call it function f. It can also be a key value. Okay. Okay, so function is for second. This I think we have enough. Then function you can do function composition. Function composition means that you can have f of g of something. Okay, so this is inner outer function. This is inner function. So inner function is printed. Okay, so your outer function calling the function is the inner function and call it. Okay, so you pass the inner function as a parameter to outer. And the outer will run outer, it will run the function of the inner function. Okay. So this is a function composition. And because of function composition, you create higher order functions as well. Okay, higher order functions. Okay. And they are callback function. Callback function means that you pass the function as parameter and call it. It's called callback function. So here, animals, you can sort animals. Okay, you got it. And then you can provide key using the length. So the length is a function. And then you use that to sort the array. Okay, so this is one parameter applying to the sorting function. Chaining, okay, chaining. Method chaining is simply able to add second function to the whatever first function return. It's called chaining. Okay. So we have inner and outer. We will return inner function. So function will be returned. Okay. So you call outer function, then you have an inner function that there. So you will be returned inner function will be returned. Okay. So this one basically is assigning outer function to function. And then this one is outer function, is a function call. So function call means that you call the outer function. Okay. And this one basically you call the outer function. So you get this. Okay. And in that case, your inner function will be returned and called. Okay. And then this one is calling your outer function. Your outer function will return the inner function, and inner function will be called. So these two both create the calling of the inner function. So it print something. Any questions so far?
No.
So to understand this kind of the functional programming, you better understand that what value being returned and function can be returned. Okay, function can be returned. So remember this one, it is calling the outer function and calling the outer function. So in fact, this one will, inner function will be returned right here. Okay, so inner function return here. So here you will call inner function. Okay, call the inner function. Okay, so next one is lambda expression. Lambda expression is a function without name. So it actually has a lambda expression and then parameter and an expression. Expression will return value. So basically the value based on the expression. So lambda expression is a function without name, but itself is also is an expression. So lambda s and then s colon minus one. This one is actually if you check it's callable or not, it will return true. Okay. So this one, if you assign this one to it, you become the reverse of the function. Okay. So this one is a function without name, but you can assign it to a object. So this one is a function, is an object, and this function because it will reverse the data. Okay, anyway, this lambda expression, I think we have enough. So here you have a function, you return x squared x cubed. Okay, when you do and that is actually returning in the tuple. So your function 3, you return a tuple of this. Okay. Okay, I think okay. Next one is a map function. Map function will apply a function as parameter to some data. Okay. So it's a function and iterable. So here we have a reverse, and this we define that is to reverse. Okay. So here we have array. You map a reverse to animal, so every single one will be reversed. Okay, when you return, every single one will be returned. You have actually you have the iterator. It says a map object, and you need to convert it back to list. Okay, map object. Sometimes you cannot see the content. You have to convert it to list or tuple. Then this can be printed. But every data will be reversed. Okay, this one I think okay. You can also map with multiple iterables. So you have iterable and then the f will be returned in each iterables. Okay. So it's applying the function to each individual ones. So function f will sum up 3 data. Okay. And you map that function f to 3 of these. So this one sum up to the first value is sum up to the second value. I'm sorry. Actually, it doesn't summarize. It sum up this one, and this one. Okay, to be the first one. Okay. Okay, this one I think here is not single iterable. This is with multiple iterable. Okay, the title is wrong. Let me change it. Okay. Composition, chaining, lambda expression, map functions. This is single iterable. Okay, these are single iterable. So let me actually copy this one. I think the page title is wrong. These are multiple iterables. Okay. So calling this one, you actually show you how the whole thing being evaluated. Okay. Okay, show you how different things got evaluated. Map with a single iterable. So you have a lambda function. Okay, so this one again is wrong. This one is also multiple iterable. Okay, so the slides, we have 2 pages that I multiplied. Next one is filter function. Okay, there are 3 major functional programming functions. That's the map, filter, and reduce. So the filter will use a Boolean value to filter out elements. So you apply a function, usually this function with a Boolean value, okay, return Boolean value, and you apply that function to the iterable to select the data, okay. So this one using greater than 100, so use a greater than 100 to actually filter it. So out, in, out, in, out, in, okay. So your remaining value is like that. Okay, this one I think very simple. So let's just go through it. Reduce function. Okay, reduce function is you have 1, 2, 3, 4. You apply the reduce function with the plus sign to reduce this to a new value, and then this new value reduce with this, and then apply with 4 with the plus sign. Okay, that is the reduce function. So reduce function is a function that apply item to the iterable 2 at a time and combine them together to produce single result. We call it aggregation. So you aggregation with some value. So you can do reduce plus to a list. So that means that you have A, B, C in the list. So you will actually reduce by adding the plus sign among them. Okay. But this reduce function is no longer supported by Python 3. So you need to do from functions import reduce, function towards import reduce. Okay. So here you have a plus sign, and then you can apply the plus sign to every data, okay, one by one. So you'll be like this. You will work like this, okay. So this one, if you want to create n factorial, you can basically do reduce, multiply, to a list of 1, 2, 3, 4, 5, 6 to n. Okay. That's n factorial. So there's a function called multiply, and then you return the reduced multiply to the range function here. Okay, that would equal to factorial. Any questions so far?
No.
Okay, so that actually give you the factorial. Okay. So here you have 100 plus sum of the foreign scene. This is 115. Okay, it's okay. So this one you have number, you map STR to it. So everybody's STR, and then so you become 1 string, 2 string, okay, whatever, up to 5 string. That's the result. And you make them a list, okay, and you print it. So it's like this. And then this one is custom map. You have function and iterable. You use a reduce, and then reduce your item and value, okay, 2 variables. So item plus functional of the value and make it a list. And then the iterable will be put there. So let's see, you actually, the function is str, your iterable is numbers. So you basically put the 1, 2, 3, 4, 5 to the iterable. So this is a list of 1, 2, 3, 4, 5. Okay. And there's a lambda function. You have the item and the value. Okay. Item and value. Item, you will be plus the functional value. Functional is str of the value. Okay. And you do reduce means like you kind of will apply this one to the iterables. Okay. And the function is a lambda function. Let's see. This is str. str will be applied to it. Okay. So you reduce that to the numbers, and then making it the list one more time. So eventually you will also get the same thing. Okay. A little bit complicated, but anyway, just doing some mental exercise. Okay. A reduce function will be returned. Okay, well, anyway. So here come up with more different kind of the custom field or whatever. You can combine them, okay? Just some mental exercise. Anyway, so here this one is the first half of functional programming. We go over the functional programming features and 3 major functional programming, like including the lambda expression, map, filter, and reduce. These are 3 major functional programming functions, okay? So give you a basic introduction for functional programming, okay? Okay, so that's it for the chapter. Any questions so far?
No.
Any question about the homework or anything else?
I think I'm okay.
Yeah, okay, okay. Anyway, so welcome. Thank you for welcome you to come over. Okay. So anyway, we will give you this session is primarily for question and answer. So if no question, that will be it for today. Okay. And then let me know if you have questions sometime. Okay. See you next time. Bye bye.